there, all you Math 6 accelerated students. Today we're doing 15-5, percent increase and percent decrease. Oh yeah! And the essential question is, how do I describe a change in quantity as a percent? Now, a change, in quantity, we have to get good at looking at words and going, well, what does that mean? If you're finding a change in quantity, that's the same as finding the difference. Like if I say something goes from 5 to 8, right? Maybe, homework assignments you have to do or something. The change in quantity from 5 to 8 is 3. How do you determine that? 8 minus 5 is 3. Okay, so that has something to do with percent change. A percent of change is the percent that a quantity changes from the original amount. And a lot of this vocab is what's hard. When I said from 5 to 8, the original amount was 5, the new amount is 8. So if you're finding the percent of change, you want to find the amount of change, that's the difference between the two numbers, as a ratio over the original amount, which in my example was 5. Now, it could decrease, right? What if I'd started at 10 and went to 7? The amount of change would still be 3. You'd find the difference of the two numbers. 10 minus 7 is 3. It's always positive, that amount. But then you put that as a ratio of the original amount was 10 in that case. So then it would be 3 over 10. And then you can convert that into a percent. Okay, amount of change is same as finding the, and I'm sorry about that blue line, it just means there's a grammatical error according to Word, is the same as finding the difference. So you must subtract to find the amount of change. And that amount of change will always be positive, always. But the a total percent increase or decrease may be positive or negative depending on which way you're going. So we'll go through that in an example. Here we go. Let's look at this example here. This says, question, how does finding the amount of change work? How does finding the amount of change work? Okay, most math problems are time dependent. There's a beginning, there's a middle, and there's an end. It's like a story. If you spend 4 hours playing some new rad, awesome, bodacious video game one day and 5 hours playing the next, there is a chronology, and that's a timeline. And that timeline is really important to understand. So let's go in order, like as if we were on a number line. The first day you spent 4 hours playing the game. This is the original amount, or the beginning, okay? The beginning. Okay. The second day you spent 5 hours playing the game. This is the end. The beginning is the original amount. Whoa. Which represents what percent? The beginning always, the original amount, the beginning always represents 100%. That's what you start with. That's 100%. We're going to see how much we change from 100%. Are we going up, are we going down, or what? Or the what? So the original amount, which represents 100%, or the beginning. So that's all connected. Beginning, original amount, 100%. The end is the new amount, or final amounts, or what you end up with. The original amount is the number or measure at the beginning, which is the, whoa, I missed on that B. I'm gonna try that again because that was pretty bad. B for bad, Mr. Plunkett. Beginning, or the earliest part of the timeline, called a chronology. The original amount represents what percent? Always 100%. Or the what? The original amount represents 100%, or the beginning. Again, I'm giving myself enough room here. That's pretty bad. The amount of change will be the blank amount minus the blank amount. The new amount minus the original amount. That's finding the difference. And frankly, it won't always be that way. I like to have a positive number in the numerator. So I typically just do whatever the greater number is and I subtract the lesser number to get a positive number in the numerator. Now, the important thing after that though, is that then you have to decide, do I have a percent increase or percent decrease? Am I going up from the original to the new amount, or am I going down from the original to the new amount? If you do it this way, the new minus the original, you might get a negative number. That just means that you have a decrease, right? If the new amount is 7 and the original amount is 10, 7 minus 10 is -3, you know that you have a percent decrease. So we'll go over that in the next example. The percent of change will be the ratio of the amount of change over the original amount. So the percent of change will be the ratio of the amount of change over the original amount, or the what? Beginning. Okay. Here is an example of all of this. Hopefully we have the mechanics there. I don't know why I made those lines so small for beginning. Maybe there's a different word I meant to have go there and I've forgotten what it was. If somebody knows what it is, tell me and I will give you a gold star. Okay, how do I determine the percent decrease? Okay, the bar graph shows the softball player's home run totals. What was the percent change from 2012 to 2013? Okay, I have the season here, 2010 through 2013. Here are the number of home runs. The years we care about are 2012 and 2013. Okay, beginning amount, the original amount was 28. So you're going to get so used to this, you're not going to need to do it, but I'm going to do it on this one. The original amount, which is also the beginning, equals 28. The new amount equals 20. Now already you should see that from going from 28 to 20, you're going to have a percent decrease, right? It's going to be a percent decrease. But how do we find this percent change? Percent change is equal to, it's going to be the difference between these divided by the original amount. The original amount is the 100%. We're going to have to find the difference into these. Now, I'm going to show you if I actually always do new minus original, 20 minus 28, I'm going to get a negative number in that numerator. That's okay. So I'm going to get -8 over 28. So my final percent change is going to be negative. And in order to find a percent change, I'm going to take, or with a fraction, I'm going to take that fraction and divide it, which is going to give me a decimal. And then from there, I can go straight to a percent. So 8 divided by 28, and I get 0.2857. Now, I don't know if you remember this, but we're going to multiply by 100, right, to get a percent. So that's going to be, the decimal is going to go over to the right twice. You can use the D2P trick. So that's about 28.6%, right? 28.6%. Okay, now here's the thing. You got to be careful on big ideas. What does that negative mean? That negative means we had a percent decrease. On big ideas, it'll say, what is the percent decrease? They don't want this negative. They just want 28.6%. Or they don't even want the percent a lot of times because the percent will already be written there. So just be careful. You have infinite check answer choices, so you should be able to finagle it to figure out what it is. But that negative is important because it tells us that the percent was decreasing. Okay, the chronology goes from the earliest year to the latest. The earliest year in the problem is 2012, and the latest year in the problem is 2013. The earliest year is the original amount, which is 100%. So that 28 was 100%. To find the percent change, find the blank between the numbers of the home runs as a ratio over the blank. Find the difference, let's write diff, period, between the numbers of the home runs as a ratio over the original amount. All right, I'm going to end this as part 1 of the video. Thank you all, you're amazing, and I'll be back in just a minute for part 2, or you're gonna have to click, I guess. Bye.